Hello friends, welcome to the course Essentials of Data Science with R Software 2, where we are trying to learn the topics of sampling theory and linear regression analysis. In this lecture, we are going to continue with the module on sampling theory with R Software, and we are going to begin with a new chapter on the sampling theory for proportions and percentage. So, from this lecture, we are going to consider the simple random sampling for a qualitative variable. When we studied the simple random sampling earlier, then we had assumed that the variable under study is quantitative. Quantitative means the observations can be obtained in a numerical way. Numerical way means, for example, if I say, suppose I have a variable height. So, height can be say 152 centimeter, 155 centimeter, 155.5 centimeter, and so on. But now there can be many situations in real life where the variables are qualitative, they are dichotomous. The variables are defined in such a way such that they takes only two possible values, and those values are actually the values of an indicator variable. For example, if I conduct a survey to judge the taste of a coffee, so the person will sip the coffee and the response will be something like good or bad. This cannot be quantified, good is good and bad is bad. Similarly, if I say the gender of the students, that can be male or female. So, under this type of situations, the first problem is this, that how to conduct the simple random sampling, how to obtain a representative sample, and after that the observation are not actually a numerical value, but these are some indicator variables like good, bad, yes, no, etc. So, how to convert them into a numerical way such that statistics can be used over that? One limitation in statistics is that the statistical tool work only on the numbers, quantitative variables. So, first we have to understand how to draw a simple random sampling with and without replacement. Then once you obtain the value of a dichotomous variable, which are essentially indicator variable, you need to convert them into some numericals, and then you would like to apply the statistical tools over them. So, in this lecture I am going to assume that you know completely about the simple random sampling, because I will be simply extending the concept of simple random sampling for quantitative variable to qualitative variable. I have two options. Either I try to teach it right from the beginning, from the scratch, as I did in the case of simple random sampling, or more intelligent option is that since we already have done the simple random sampling, so why not to make a one-to-one connection between the simple random sampling of qualitative variable and quantitative variable. Once I am able to establish the connection between the two, then I can use the tools of simple random sampling that we already have developed directly for the cases when the x is dichotomous variable or an indicator variable or a qualitative variable. So, let us begin this lecture with these concepts. Okay. So, now we are going to consider the sampling for proportion and percentages. What does this mean? I will try to explain you in the forthcoming slides. In many situations, the characteristic under study on which the observations are collected are qualitative in nature. For example, the responses of our customers in many marketing surveys can be like yes or no, or they can be like agree or disagree. Simply for a gender, there can be two categories, male and female. So the question is this: what to do in these situations? The next scenario can be where the respondents are asked to order the several options. If there are 3 choices of a drink, say coffee, tea, or some juice. So if you ask someone, then usually the person will like all the things, but then we ask them, can you please order it? What is your first choice, what is your second choice, and what is your third choice? So the answer can be from one respondent like as tea, coffee and juice, whereas another respondent may say juice, coffee and tea, and so on. So this is what I mean when I say that the respondents are asked to order the options. Similarly, there can be many situations that we want to have a survey of people who have got say brown eyes, the survey on the status of the person, that the person is employed or say unemployed, the education of the person, that the persons can be divided into say these 2 groups, whether the person is graduate or a non-graduate, or if there is some proposal, there can be 2 groups, one group where the people are favoring a proposal, and in second group people who are not favoring a proposal. So in such situation, we are more interested in estimating the proportion or the percentage of people or the observation in one group and in the second group. So in such a condition, in such a situation, the first question arises is how to do the sampling, and the next condition is this: how to estimate the population parameters. Population parameters of interest are like population mean and population variance that we discuss in the case of simple random sampling for qualitative variables. So under this situation, the answer of the first question, that how to do the sampling, is very straightforward. We are going to use the same sampling procedure what we have used in the case of quantitative characteristics for drawing a sample. That will be the same process that we will follow for the qualitative variable also, qualitative characteristic also. So up to now we have done 2 sampling procedures: simple random sampling without replacement and simple random sampling with replacement for drawing the sample. So the procedure that how are we going to draw the samples, this will remain exactly the same in case of qualitative characteristic, just like in the case of quantitative characteristic. And whatever concept we have developed in case of SRS-WOR and SRS-WR, they will be followed exactly in the same way with some modification. Okay, now let us try to first understand how is the population and how are we going to draw the sample, and then how are we going to do the mathematical manipulations. By mathematical manipulations means how are we going to handle the observations so that they can be used over a statistical tool like as mean, variance, etc. So suppose we have here a population, and this population has got capital a number of units, and this population is divided into 2 groups, or we call it that population is divided into 2 classes. Those classes are denoted by C and C star. For example, the population can be of the people who want to give their opinion on a proposal. So there will be 2 classes, one class which says that they are in the favor of the proposal, and the second case where the persons are not in the favor of the proposal. So we assume that out of capital N, suppose there are capital A number of units which belong to class C. That means A persons are there who are favoring the proposal, and there are obviously then the remaining units which are capital N minus A, they will belong to the second class. So we are assuming that these two classes are mutually exclusive. This means there is no unit which can belong to both the classes. So the condition is this: a unit can belong only to one of the two classes, either C or C star. So in such cases, if you try to see here, if you want to estimate the population proportion, which is our basic objective whenever we are trying to deal with the qualitative characteristic. So the population proportion in this class C, that is going to be the number of units in the class C, which is here A, divided by the total number of units in the population, that is N. So the population proportion is defined and indicated here by capital P. So capital P is equal to capital A upon capital N. Then obviously the proportion of the people or the proportion of the units in the class C star, which is the complementary class of C, this will become the remaining units, which is capital N minus A divided by total number of units in the class C star, and this proportion is denoted by Q, capital Q. So for the population proportion, we are using the symbols capital letters P and capital letters Q. So now this Q can be expressed as 1 minus A upon N, which is same as 1 minus P. So you can see here that now we have a relationship that Q plus P should be equal to 1. Now what we try to do, we have to draw a sample. So now you can see here we have a population here which is divided into two classes, class C and C star, and from there we try to draw a sample. So suppose we want to draw a sample of size small n. So small n is my here sample size. So what I try to draw? I try to draw a small n number of units from this population. Now when I have drawn a small n number of units from this population, so obviously in the sample there will be two types of units. One set of unit which belongs to class C, and say another set of unit which belongs to class C star. So suppose we assume that the number of sampling units in the sample which belong to class C are small a. So there are small a number of units in the sample which are belonging to class C, and obviously the remaining unit which are small n number minus small a number, this number of units will belong to the complementary class C star. So what is really happening? Suppose we have a population of people who are going to opine on some proposal. So in the population, suppose there are 100 persons. Obviously in this group there will be 2 persons who are saying yes to the proposal and who are saying no to the proposal. Now suppose I try to draw here a sample of size 30 persons. Now in this sample also there will be 2 types of person who are saying yes and who are saying no. So the number of persons who are saying yes in the population, this is here A, and the number of persons who are saying no in the population, this is capital N minus A. The number of persons who are saying yes in the sample, this is small a, and the number of persons who are saying no in the sample, this is small n minus small a. So this is my setup. Now when I am trying to draw the sample from the population of size capital N, and suppose we draw a sample of size small n, then this sample can be selected by simple random sampling. and that will be your choice, that will be the condition of the experiment which will help you in making a call that whether you want to follow a simple random sampling with replacement or simple random sampling without replacement. So, both these things are possible. So, now as the procedure of selection of a unit is concerned, this is exactly the same as we discussed in the case of simple random sampling. So, I am not going to repeat it, but you have to recall, or else if you cannot recall, please try to go through with the earlier lectures. Okay, now I have got here a sample of a small number of units in which there are two types of samples. One sample consisting of a small a number of units from the class C, and the remaining units n minus a which belongs to class C star. So, now exactly on the same way as we have found the population proportion, we can also find the sample proportion. That means the number of persons belonging to class C and number of persons belonging to class C star, they will constitute the sample proportion as follows. The sample proportion for the class C will be indicated by small p, and this is the total number of units which is small a divided by the total number of units which is small n, and the sample proportion of the units belonging to class C star, that will be denoted by small q. And obviously, this is the total number of units in the class C star, which is n minus a, divided by the total number of units in the sample, which is small n. So, this can also be written as 1 minus a upon n, which is the same as 1 minus p. So, you can see here we are denoting the population proportion by capital letters P and Q, and the sample proportions are denoted by small p and small q, right. And there was a relationship for the population P plus Q equal to 1, and similarly we have a condition small p plus small q is equal to 1 from the sample. So, this is our basic setup. Now, let me try to give you one more example to make you understand better. So, suppose we have here a population of size capital N is equal to 10. So, what I have done, suppose there was an experiment to taste a coffee. So, capital N is equal to 10 number of people were asked to drink the coffee, and after that their reactions were recorded. So, you can see here I have used here two symbols, two smileys, two faces. One is here in yellow and another here is in red. So, yellow faces are indicating that okay, the taste was good and the person is happy after drinking the tea, whereas the red faces which are indicating that the person is not happy after drinking the tea. So, you can see here that I have here 6 person 1, 2, 3, 4, 5 and here 6 which are happy with the taste of the coffee, and there are 4, 1, 2, 3 and here 4 persons who could not like the taste of the coffee. So, I can divide them into two possible classes. One is the class of people who are happy. So, there are here capital A is equal to 6, and second class where the people are not happy with the taste of the coffee. This consists of class C star with n minus a which is equal to 10 minus 6 is equal to 4 number of units. Now, I try to draw a sample from this population and I try to draw say 5 number of units. So, my small n is equal to here 5, and in order to draw the samples I have two options. I can use simple random sampling without replacement or simple random sampling with replacement. Now, in the sample also there will be two types of people, one who are happy and one who are not happy. So, you can see here in the sample there are 1, 2 and 3 persons who are happy who belong to the class C, and there are 2 persons who are not happy, so they belong to the class C star. So, here small a is equal to here 3 and small n minus a will be equal to 5 minus 3 is equal to 2, right. So, if you come back to population, in the case of population, we have the population proportion of the people who are happy is 6 upon 10, and the people who are not happy with the taste of the coffee, this is capital Q, this is 4 upon 10. So, now the problem is this, that these two values of capital P and capital Q, which I am marking here in color red, they are unknown to us because they belong to population. Now, what I try to do? I try to compute the sample proportion from the sample, say small p, number of people who are happy with the taste of the coffee, which is 3 upon 5, and the number of persons who are not happy with the taste of the coffee, which is 2 upon 5. So, now my question is this here, that this capital P and capital Q, that is not known to us. You can see here I have hided it with the blue pen. So, you do not know, you simply know that these proportions are capital P and capital Q, and you want to estimate the value of capital P on the basis of the sample. So, the question is this, how are you going to estimate this population proportion capital P or equivalently the capital Q? So, now capital N is the population size from where we are going to draw the sample, and I am introducing here one symbol capital X. So, this is going to indicate the qualitative characteristic under study. Remember, I am saying this is qualitative variable. Qualitative variable means it is something like yes or no or good or bad, and these two characteristics have been divided into two mutually exclusive classes which are based on capital X, the qualitative characteristic. For example, X can be a variable like opinion of persons on a proposal. So, there will be some person who will be saying yes or they will agree with the proposal, then this is my here class C, and the remaining people who are saying no or they are not agreeing or they are disagreeing with the proposal, that is inside the class C star. Okay. So, similarly, if I say X is the gender of the students in the classes, so C is the part of the population of male student and C star will be the part of the population corresponding to the female students. So, similarly, there can be many more examples. So, as we have discussed in the earlier diagram, capital A is the number of units in class C, and then obviously capital N minus capital A is the number of units in class C star, and then the proportion of the units in class C is denoted by capital P is equal to capital A upon N, and the population proportion of the units in the class C star is denoted by Q, as we have already discussed. This is N minus A upon N, and which is same as 1 minus A upon N, and this is same as 1 minus capital P. Right. So, this capital P is something like the population proportion of persons who are saying yes or they are agreeing with the proposal as in the earlier example, and Q is the complement of this. So, Q is the population proportion of persons saying no or they are not agreeing with the proposal. Now, from this population of size capital N, we are going to draw a sample of size small n by simple random sampling, that can be SRSWR or SRSWOR. And from this sample, we try to count the number of units which fall into the class C, and we are indicating this number by small a. Then obviously, small n minus small a will be the number of units that falls in class C star. So, now from this sample also we try to estimate we try to find out the sample proportion. the sample proportion of the units belonging to class C is indicated by small p, which is equal to small a upon small n, and the sample proportion of the units in class C star, this is small q is equal to small n minus a upon n, which is 1 minus a upon n, which is equal to 1 minus small p. So you can see here, once again I will reiterate that P plus capital Q is equal to 1, and small p plus small q is also equal to 1. Okay, so now this is our setup. But you have to remember one thing. We have defined here capital X, and capital X is qualitative. The problem with the qualitative variable from the statistical point of view is that no statistical tool can be used on these values, which are in terms of say yes or no or good or bad. But we need to convert these values on the capital X to some quantitative variable. Say, let me denote this quantitative variable by capital Y. So now I am saying that capital Y is the variable which is quantitative, and in such a cases you will agree with me that it is a big issue that how to indicate this good or bad or yes or no, because they are only indicating the absence or the presence of the characteristic. They are not quantifying it. For example, if I say height is equal to 150 centimeter and say and height is equal to 170 centimeter, that indicates that the person with height 170 centimeter is taller than the person who is having the height 150 centimeter. But in case of indicator variable, this is not possible, because somebody is saying say y. So how y is good or bad? So how to quantify it? So we assume that y is an indicator variable. What do we mean by indicator variable? So then the meaning of indicator variable is this: it is only indicating the absence or presence by some numerical value. There is no concept of magnitude. For example, if I say y is equal to 1 if person likes the coffee, and 0 if the person does not like the coffee. Right. So 1 and 0, they are only indicating the absence or presence of the taste for a particular person. And in case if you ask me, I can also define it in the opposite way. For example, I can define y equal to 0 if a person likes the coffee and 1 if the person does not like the coffee. So that is the choice of the experimenter, that what he chooses. Here, in order to proceed further, we assume that y takes value 1 and 0, and 1 is indicating the class C and 0 is indicating the class C star. So now I have collected a sample from a population of size capital N. So what will happen in the case of population? There are units which we have denoted earlier by y1, y2 up to here yn. So now this y1, y2, yn, they are the capital N number of persons in the population, and now they are trying to indicate their response, whether they like the coffee or not. So suppose I assume that yi, which is the response of the ith unit, this takes value 1 or 0. 1 is indicating that the response belongs to class C, and 0 indicates that the response belongs to class C star. Right. Okay. Now, based on this y, we have to proceed further. So now what you can do, I have made here a one-to-one correspondence between capital X and capital Y. Capital X was qualitative and capital Y is quantitative. And I have made here the one-to-one correspondence between the two. Yeah, 1-to-1 correspondence does not mean that by looking at the value of y you can determine the value of x, means unless and until their order or position is not known to us. Right. Okay. So first let me define the population value. So the population total is indicated by here y total, and this is summation I goes from 1 to capital N, capital YI, and which is going to take a value here something like 1 plus 0 plus 0 plus 1 up to here n values. So now you can see here you have assumed that the number of units which are belonging to class C are here capital A, and these values are denoted by 1. So now this is going to be 1 plus 1 plus 1 up to capital A times. So this will be equal to here capital A. So the y total becomes here capital A. Now in case if you go for population mean capital Y bar is 1 upon capital N, I goes from 1 to capital N, capital YI. So this value here is capital A in the numerator, and in the denominator this is capital N, the population size. So you can recall that this quantity capital A upon capital N is population proportion capital P. And similarly for the sample mean small y bar, that is 1 upon small n, summation I goes from 1 to n yi. So this number you have seen that in the sample there are a small a number of units which are in class C. So this summation I goes from 1 to small and yi will be something like 1 plus 0 plus 1 up to here small n values. And out of this small n values there will be 1 plus 1 plus 1 small a number of values. So the sum will become here small a upon small n, which is your sample proportion small p. So now you can see here that I have made here 1-to-1 correspondence between the capital X and capital Y in terms of population total, population mean and sample mean. Similarly, I can make a 1-to-1 correspondence between the quantities related to the variance. So for example, you had earlier considered a quantity capital S square, which was defined here like this 1 upon capital N minus 1 summation I goes from 1 to n yi minus capital Y bar whole square. Now, so what you have to see here is the following. This quantity can be expressed as like this, which we discussed in the earlier lecture, 1 upon capital N minus 1 summation yi square minus n times y bar square. Now if you try to see this yi takes here value 1 and 0 if a unit belongs to class C or if the unit belongs to class C star. Now in case if you try to find out the value of yi square, this will also be 1 square which is equal to here 1 and 0 square which is equal to here 0 if the person or the unit belong to class C or if the unit belong to class C star. So in case if you try to find out the value of I goes from here 1 to n capital Y square, this is going to be a value like 1 square plus 0 square plus 1 square and so on capital N values. And so this is going to be 1 plus 1 plus 1 how many times? Capital A times. So this is your here, see here A, and A here is nothing but capital N times capital P. So that is what I am trying to use here. Right, and for about capital Y bar you already have proved that this is equal to capital P. So this quantity can be written here as a in place of summation yi square I can have here capital N into P, and in case of n times y bar square I have here n P square. So this quantity is nothing but your 1 over n minus 1 np times 1 minus p, which is nothing but your n upon n minus 1 times capital P into capital Q. So you can see here now I have made 1-to-1 correspondence between the quantity capital S square when the variables are transformed from quantitative to qualitative. So the same exercise can be done on the small s square also. If you remember, say small s square we have defined as the sample version of the capital S square, 1 upon small n minus 1, I goes from 1 to n yi minus y bar whole square. So, this quantity will come out to be summation I goes from 1 to n yi square minus small n times small y bar whole square. So, mean as exactly on the same way I goes from 1 to n yi square will be something like 1 square plus 0 square, and there will be such n values. And so, this will be 1 plus 1 plus 1 a times. So, this is nothing but your a, and a is you simply here small n into small p, and y bar was already you have proved this is small p. So, this quantity can be written here like this, summation yi square will be n times p and n times y bar square will be n p square, and finally, this will come out to be here n upon n minus 1 p 1 minus p, which is your here n upon n minus 1 p into q, right. So, briefly I can comprehend these values here, all the values in this slide. Whatever was your population mean in case of qualitative variable capital Y bar, this is now converted to capital P, and whatever was your capital S square in case of quantitative variable, this is now converted to capital n upon capital N minus 1 times p q in case of qualitative variable, and similarly is the story in the case of sample also. So, now in this lecture I will stop here. What I have done that I simply have transformed the quantities that we use in the case of simple random sampling, like as a small y bar, capital Y bar and capital S square, which were defined for a quantitative variable. I have transformed them to the setup of qualitative variable. Now, you can recall that whatever properties we had studied in case of simple random sampling, and that either finding out the properties of sample mean, properties of sample variance, the variance of sample mean, the estimate of variance of sample mean, they can directly be converted into the setup of a qualitative variable. So, this topic I will try to take up in the next lecture, and I am stopping here because I want to give you some time so that you can refresh your concepts and terms that you studied during the simple random sampling. So, on the next turn, please come with a quick revision of what was a small y bar, what were the properties of a small y bar like as biased or say unbiased, how we have found the variance of y bar in case of SRS WOR and WR, and how we have estimated the variance of a small y bar in case of SRS WR and WOR. Right. We also constructed the confidence interval. So, you just try to have a quick review of those concepts, and I will see you in the next lecture. Till then, goodbye.